In this video, we're going to use the arc-length formula. We are going to use the arc-length formula to confirm that the circumference of a circle is indeed 2 pi r. So we are going to work out a quarter of a circle. So our arc is a quarter of a circle. Right at the end, we can multiply by 4. So the arc-length formula is given by this, which we've seen in the past. In order to work out the arc-length, we need to extract dy by dx. So looking at the equation of a circle, we need to rearrange it to make y the subject. So take away x squared, so that will then give us this, and then square root both sides. That will then give you this. So when you square root, you're going to get a positive version and a negative version. The positive version will represent this, the positive side, and the negative version will represent this. We are going to discard the negative version. So we're going to discard the negative version and just look at the positive one. So to work out the arc length, we are going to integrate it from 0 to r. So we're summing up all the lengths here. We're summing up all the lengths from 0 to r, in the x direction, in the dx direction. So looking at this formula here, we would need to extract dy by dx. So this is y here. We need to work out dy by dx. So differentiate it. That will then give you this thing here. And then looking at the formula, you need to, once you've got your dy by dx, you need to square it. So we now need to square it. So squaring it will then give us this. So we can now put this back into here. That will then give us this. That will then give us this. So now we need to merge these two blocks together. So visualize the 1 as this thing divided by its exact same self. So this here is the number 1. So 1 plus this thing. Now same denominator. So you can merge the two numerators. So that will then give you this. So using this, square rooting the whole thing is the same as you square rooting the numerator and square rooting the denominator. That will then give you, well, when you square root a square, that will then give you this. Square root the denominator, that will then give you this. So we are integrating from 0 to r of this thing in the x direction. So in order to integrate this, remember this thing's hard to integrate because you've got x squared here and well, this thing here is hard to integrate. You've got to use trigonometric substitution. So create a triangle. Well, to do this, your eyes has to zoom into this thing here. Create a triangle in such a way that this thing will be true. Well, if you make the hypotenuse to be r and the opposite to be x, then the adjacent will have no choice but to be square root r squared minus x squared. So now looking at this, sine the angle equals x over r. So make x a subject. So times both sides by this. But remember, in order to integrate this, we've got to create a triangle in such a way that this thing will be true. But we need to extract this dx. The way we would do that is to look at this thing here. So times both sides by r, that will then give us this. So we need to somehow extract this dx. So once you're here, find the differentials of both sides. So differentiate it. That will then give you this d theta. Differentiate this would be 1 and then dx. So now you've got your dx. So later on you can put this back into here. And then looking at this complicated thing here, well, this complicated thing here is, if you look at cos the angle equals that complicated thing, r squared minus x squared, divided by the hypotenuse, and then times both sides by r. That will then give you this thing here. So you can now put this into this complicated thing here. You can put this into this dx thing here. So that will then give you this. And remember, we are now working in terms of theta, not in terms of x. So here we are integrating from x equals 0 to x equals r. But because we are now working in terms of theta, we need to keep it as x equals 0, x equals r. Later on, we would translate all the thetas back in terms of x. Okay, but for the time being, we are now working in terms of theta. So we need to maintain that x is from 0 to x equals r. Well, anyway, from here, that will then take us to here. So now it's just a matter of integrating this with respect to theta. So simplify this. This will cancel out with this, and one of the r's will cancel out, giving you this. So now integrate this with respect to theta. So that will then give you this. So the answer. So when you integrate this, it will give you. Remember, r is just a constant. So when you integrate it with respect to theta, it's r, the constant, times theta. But we don't want the answer in terms of theta. So we will need to go back to our original diagram and then translate this theta. Well, if you look at this, sine the angle equals opposite over hypotenuse. Opposite over hypotenuse. We want theta. We want theta. So inverse sine equally to both sides. That will then give you this. So theta is this thing here. So we can now put this back into here. So this block here will then become this. So now here we are. Well, this is x equals r, x equals 0. But now because we've translated theta back into x, we can discard this. So we can just say we are integrating from 0 to r, because everything now is in terms of x. So now put this into here. That will then, that r divided by r is 1, and then put this into here. 0 divided by r will be 0. So it boils down to this thing here. So what is inverse sine of 1? Well, if you look at the sine graph, it looks like this. 1 is here. So inverse sine of 1 is pi over 2. Pi over 2. What is inverse sine of 0? Inverse sine of 0 will be 0. So the arc, a quarter of a circle, which is our arc, is given by this. So the whole circumference is when you multiply this by 4. Multiply by 4. So multiplying by 4 will then give you 2 pi r, which is the circumference of a circle. So here we are just merely confirming the formula for the arc length. So if you work out this arc length and multiply by 4, it does give you the circumference of a circle. Okay.